Right. Today we're going to be looking at the properties of logarithms. This is Chapter 7, Topic 6. There are three properties that we'll be using, and these will allow us to solve logarithmic equations. There's the product property that says that log b of x times y can be rewritten as log b of x plus log b of y. Quotient property, which says that log b of x divided by y can be rewritten as log base b of x minus log base b of y. So you can split it up into subtraction. And the power property says log base b of x to the n power can be rewritten as n times log base b of x. We're going to use these to help us solve some logarithmic equations. So log base 6 of x plus log base 6 of x minus 9 equals 2. And we're going to solve these. Now keep in mind, we may get multiple solutions and we have to check to see which solutions work, because not all your solutions are going to work. Alright, so this would be the product property. Okay, we have addition between the two logarithms, so we can combine those into a single logarithm, log 6, where the arguments are multiplied together, where x and x minus 9 are multiplied together to be x times x minus 9 equals 2. Okay, so this is log base 6 of x squared minus 9x equals 2. All right, and now we can rewrite this as an exponent. Okay, so this would be 6 to the second power equals x squared minus 9x. Okay, so that's 36 equals x squared minus 9x. And if we move the 36 to the other side, because we have to solve this as a quadratic, which means we have to set it equal to 0, now we can solve this quadratic. So we're looking for numbers that multiply to 36 and add to negative 9. And that would be 12 and 3. This is negative 12 times 3. This is negative 12 plus 3. All right, so this can be rewritten as x. This can be factored as x minus 12 and x plus 3. So we can see that we have two possible solutions. We have 12 and we have negative 3. One of these is going to work and one of them are not going to work. Okay, the one that gives a negative inside the log is not going to work. So negative 3 is not going to work. 12 is our solution to number 1. Number 2, we have 2 log base 7 of x equals log base 7 of 81. Okay, now this is the power property. Okay, we have 2 times log base 7 of x, which means that we can put it inside the logarithm and make it an exponent. This is log base 7 of x squared equals log base 7 of 81. Since these both sides have the same logarithm with the same base, we can just set these equal to each other. X squared equals 81. I don't need to factor this one because there's no b value. I don't need to set it equal to 0 and factor this. I can just solve this using the square root method. I can square root both sides. Don't forget the plus or minus. So I got x is equal to plus or minus 9. So that's two possible solutions, 9 and negative 9. Now one of these is not going to work because it's going to give a negative under the radical. And the one that gives a negative under the radical, in the logarithm, is this one. Okay, if I plug that in here, that becomes negative 9, and you can't do that. So this will be our solution, positive 9. That one will work. right, number 3, we have log 3 of 56 minus log 3 of n equals log 3 of 7. Oops. Okay, now this is the quotient property because we are subtracting here, which says that if we're subtracting two logarithms, they can be combined into a single logarithm where this is being divided by this, where 56 is being divided by n equals log base 3 of 7. Since these are logs with the same base 3, we can set them equal to each other. 56 over n equals 7. And then we can solve this for n. So multiply by n to bring it to the numerator. So 56 equals 7n. Divide by 7, n is equal to 8. So our solution to number 3 will be 8. Number 4, log base 2 of 4x plus log base 2 of 5 equals log base 2 of 40. Alright, so this is the product property because they're being added, which says we can combine them into a single logarithm with a base of 2, and we can multiply them together. 4x times 5, which is 20x, equals log base 2 of 40. They're both log base 2, so we can just set them equal to each other. 20x equals 40, and then solve for x by dividing by 20. So x is equal to 2. Number 5, we got 5 log base 2 of x equals log base 2 of 32. Alright, so this is 5 times log base 2 of x, so that's the power property. So I can rewrite this with everything inside. This can be x to the 5th equals log base 2 of 32. Now that these are both log base 2, I can set the insides equal to each other. Whoops, that's not a squared, that's a fifth. X to the 5th is equal to 32. So I can solve this by taking the 5th root of both sides. So x is equal to 2. And that is my solution. X is equal to 2. And then number 6, log base 3 of x squared plus 3 plus log base 3 of 3 equals 3. So I can combine these into a single logarithm because they're being added, which means I can combine them by multiplying 3. So that would be 3x squared plus 9, multiplying x squared plus 3 times 3. And now I can convert this to an exponent, so 3 to the third power is equal to 3x squared plus 9. So 27 equals 3x squared plus 9. All right, now there's no b value here for this quadratic, so I can solve it using the square root method. So I'll subtract 9. 18 equals 3x squared. Divide by 3. 6 is equal to x squared. I can square root both sides. Don't forget plus or minus. So x is equal to plus or minus the square root of 6. Whoops, I shouldn't circle it because it's either square root of 6 or negative square root of 6. And it actually looks like both of them will work here, okay, because neither of them is going to give a negative in the logarithm, because that would be square root of 6 squared is 6, and the square root of negative 6 squared, negative square root of 6 squared is 6 as well. So it looks like both of these are actually going to work for number 6. We would say the solutions here are square root of 6 and negative square root of 6. They both work here. Neither of these give a negative in the logarithm. All right, and then here's the homework.